Hello and welcome to this session. In this session, we will concentrate on next module of your engineering graphics. In this topic, we will learn about what are solids and what are the different types of solids that we are going to consider in the engineering graphics. So generally, you did plane problems. As you need to know what is the difference between plane and solids. So just I will focus it on simple things I will share you between planes and solids. So plane, you know that it has a surface and the thickness in this case is negligible. Thickness is negligible. For example, we did the problem on square, right, where the thickness is quite small. We will neglect the thickness compared to the dimensions which you have, the length as well as breadth. The thickness is very small, so that we will be neglecting the thickness and we will consider the surface. So these are called planes, and we have discussed these different types of planes in our discussion in orthographic projection of planes. Similarly, solids are the objects where you can't neglect the thickness because it has a considerable amount. For example, if I take a square, I need to, if I have the object like this, where the thickness is not negligible in this case, it is more compared to the length and breadth of the component. For that reason, solids are the objects which are three-dimensional, and you need to consider all the dimensions of the object. That is the basic thing you need to know. We have different types of solids that we will discuss in the presentation, so that we will learn in this. So here I will highlight which are those solids. There are two categories you can able to observe in this case. One is solids which have top and base of same shape. That means top of the solid and bottom of the solid will be having same shape. And one more group of solids which are of, in that base is of some shape and top is a point. Top face will be a point, and that point we call it as apex. See, in this case we will have some examples or some types we will discuss. You can see cylinder. For example, you see the bottom surface and the top surface are both the same. So whenever you have bottom and top surface as same, then we can call that as one type of solid. This is comes under group A. Top and base, this is the top and this is the base. Both are of same shape. Similarly, we have prisms. So prisms are nothing but where here also you see top and bottom or the base will have the same shape. It is a triangle, right? This is a triangle. Both are of same shape. So these we call it as triangular prism. Similarly, we have square. So square, top shape is also square, bottom shape is, base shape is also square. So this type of thing we call it as a square prism. Similarly, you see that here the top is pentagon, but bottom is also pentagon. So this we call it as a pentagonal prism. Similarly, we have hexagonal prism. One thing you need to note here, all the surrounding surfaces of this solid are surrounded by the rectangles here. You see, this is a rectangle, this is a rectangle, this is a rectangle. It is surrounded by a rectangle here. So here we have 5 rectangles since it is a 5 sides. Here we have 4 rectangles, here we have 3 rectangles. Just to know the difference, okay. Then we have a cube. cube is also belongs to group A, where top, bottom, even the sides are also having same shape. Sides are also having same shape. In this we have 6 square faces. You need to understand these have 6 square faces, all are equal. That's why we call it as a cube, or it's also called as, very important, it is also called as hexahedron. It's also called as hexahedron, okay, because hexa 6 and hedron equal faces, so 6 equal faces a cube will be having. Then in coming to group B, we have a top, a point, and bottom shape. So this type of solids we call it as a pyramid. So you see, I will show you in this. I have shown you a cone here, and here I am showing the a triangle. Bottom shape is a triangle, and top is, there is a apex, right? Top point we call it as apex, and bottom we have triangle. So this we call it as a triangular pyramid. Similarly, we have square at the bottom, and top there is a point apex. This we call it as square pyramid. Similarly, pentagon, and there is a point on the top. This is a pentagonal pyramid, and this is the final one. It is hexagon at the bottom. Top it is a point, so it is a hexagonal pyramid. So you can see the difference between prism and pyramid. These are surroundings. Prisms are surrounded by a rectangle. Prisms are surrounded by rectangle, but whereas pyramids are surrounded by triangle. You can see pyramids are surrounded by triangle. Here there is 3 triangle, here there is 4 triangle, here there is 5 triangle, here there is 6 triangles. See these triangle you can able to see here. Since there are 6 sides, we have 6 triangles. Here also same thing, since we have 6 sides in the prism, we have 6 rectangular faces. So that thereby pyramids differ from prisms. Okay. Next you see here also base is a triangle, and here the surrounding faces are also equal. So tetrahedron is nothing but, tetra is nothing but 4, hedron equal faces. So 4 equal faces will be there, and all 4 equal faces will be your equilateral triangle. All 4 faces will be your equilateral triangle. So it has 4 equilateral triangle. All shape whatever you get here, one bottom, sides we have 3 sides you will get. So totally 4 faces. All 4 faces are equal, and all 4 faces are equilateral triangle. So cube, you see that 6 equal faces. Here we see that 4 equal faces. But here the bottom will be a triangle, top will be a point. Here all 6 sides are same in this case. So this is the difference between solids. So different types of solids. We have learned about cylinder, prisms, pyramids, the different types of pyramids, and a cone, cylinder, and cube and tetrahedron. Next we will understand, very important, the dimensional parameters of different solids. So let us learn 3 things, 4 solids I will consider. Observe, in this case a square prism, different parameters we will call while doing the problem. We say that in planes you had if I consider triangle, it can rest on edge, it can rest on corner. You should know the parameters what we call. So same thing in the prism, we have different parameters that we need to know. So this top thing is called as a top. This is the rectangular face, this is longer edge. You see, this is a longer edge compared to other edges, and then you see this is the called as a corner of the base. These are all corner of the base, and this is the edge of the base. That means edges of the bottom portion, we call it as edges of the base, and that we call it as a base. This surface we call it as base. And here, as I told you, top portion of the pyramid is a point, and that point we call it as apex, and this is a slant edge, and which is a triangular face. Since it is inclined, we call this as a slant edge. And similarly, this is base, this is the edge of the base, and similarly corner of the base, this is a corner of the base, and this is a triangular face. You see that it is surrounded by a triangle. This face we call it as triangular face. And most important thing in cylinders and cone, you see that these lines are not made. Actually, these lines are not present in the cylinder, but we will call these lines, which are called as imaginary lines, which are drawing. So you see that it is an imaginary line drawn, generated on the curved surface of the cylinder and cone. This is just a representation where, while doing the problem, it is just a connection between the top face and the bottom face by a straight line, and these lines are imaginary lines, and these we call it as a generators. These we call it as a generators. In the problem, they might give you the cone will be resting on one of its generators, so it will be present like this, so like this on HP. So likewise, so generators are the parameter we will define in the cylinders and cone only. And this is the base of the cone. Similarly, this we call it as apex, and this we call it as a base. And here you see that there are another parameters that actually it is not there in your solids, but thing is, it is important to know these things. It is nothing but where these are called as truncated solids. In this you see that this is actually the cone. Whatever we have taken here, this is actually the cone, but the cutting, it has been, imagine the cone is like this, imagine the cone is like this. We have cutted that cone in this direction. We made a section. If I cut the cone like this, where you see that if I cut the cone like this, it will looks as if it is the shape. You can see the top shape and the bottom shape. If I see, both are not parallel, so this we call it as truncated cone, where the sections which we cut the cone, it is section is inclined. If I cut the section like this, inclined, then the top face and the bottom face are not parallel and not equal, not parallel mainly. So that type of solids we call it as truncated solids. Here truncated cone is there, here truncated cylinder is there, where here also the section which has been cutted, it is inclined section. So this type of solid, this is a truncated cylinder. You see, this is the truncated square pyramid. Bottom it is a square, but the section which I have cutted that pyramid is inclined. So that's why the top face and the bottom face are not parallel. So whenever it is not parallel, you say that it is a truncated solid. Similarly, we have one more case where that type of solids we call it as frustum only when the top shape and the bottom shape are parallel. Top shape and the bottom shape, you see here both are parallel. Why? Because the section which I cut the plane or section which I cut the solid is straight. You see if I imagine this is a cone, if I cut like this, then the top face entirely cutted and the top surface and the bottom surface will be parallel. So thereby we call that type of solids are frustum of here I have shown frustum of square pyramid, and this is the frustum of cone. So these are very important in case of development of solids. Any of this will be not there in your solids problem. Only you need to understand different parameters involved: square prism, square pyramid, what are the terms, slant edge, triangular face, base, all these things are required. So I hope you have understood this. In the next case we will be doing the problems. Okay, for problems, which are the important points to consider, that I will be sharing you in the class. So thank you for watching. I hope you have understood this. In the class I will be shortly explaining this, and I will be starting with the problem. Thank you for watching.